the Tucker engine. In 1948, Preston Tucker unveiled the Tucker 48, a revolutionary car with features decades ahead of its time. But the real innovation was the engine. Tucker commissioned a flat-six engine designed by Ben Parsons that was unlike anything in production. The Tucker engine had aluminum block and heads when most engines were cast iron. It used hemispherical combustion chambers for better efficiency. It had hydraulic valve lifters that required no adjustment. The engine was designed for extreme reliability and long life. Tucker's specifications demanded an engine that would run 150,000 miles without major service. In 1948, most engines needed rebuilds by 50,000 miles. Tucker wanted triple the durability. The engine delivered. The prototype engines ran for months in testing without failures. They exceeded power targets while achieving better fuel economy than competing engines. The aluminum construction reduced weight, improving handling and efficiency. Everything about the engine was superior to what Detroit was producing. Tucker planned to build 50,000 cars the first year. He had 150,000 advance orders. Dealers across America wanted Tucker franchises. The car and engine were ready for production. Then everything fell apart. The big three, GM, Ford, Chrysler, recognized the Tucker as an existential threat. If Tucker's reliable, efficient engine succeeded, customers would expect the same from Detroit. Planned obsolescence would be exposed. Cars that lasted 150,000 miles would destroy the replacement market. The big three used their political connections to destroy Tucker. The SEC launched an investigation into Tucker's finances, claiming fraud. The charges were baseless. Tucker was later acquitted on all counts. But the investigation froze his assets and scared off investors. Steel suppliers refused to sell to Tucker. They all had contracts with the big three and were pressured to deny Tucker materials. Parts suppliers did the same. Tucker couldn't source components because Detroit controlled the entire supply chain. Tucker managed to build 51 cars before his company collapsed in 1949. Those 51 cars proved the engine's quality. Many are still running today. Over 70 years later, the engines never needed rebuilding. They proved Tucker's 150,000-mile durability claim was conservative. The SEC investigation destroyed Tucker Corporation. Preston Tucker was prosecuted for fraud in a trial that was clearly politically motivated. He was acquitted of all charges in 1950, but his company was destroyed. The engines, the tooling, the designs, all disappeared. The big three got what they wanted. A reliable, efficient engine that threatened planned obsolescence was eliminated. Detroit continued building engines designed to wear out, ensuring customers needed regular replacements. Tucker's crime wasn't fraud. It was building something that lasted too long. The Pogue Carburetor. In the 1930s, Canadian inventor Charles Nelson Pogue developed a carburetor that reportedly achieved over 200 miles per gallon. Multiple witnesses testified to seeing Pogue's car travel from Winnipeg to Ottawa, over 1,400 miles, on less than 15 gallons of gasoline. The Pogue carburetor worked by heating fuel to high temperatures, vaporizing it completely before mixing with air. Standard carburetors only partially vaporize fuel. Much of it enters cylinders as droplets that burn incompletely. Pogue's design achieved complete vaporization, dramatically improving combustion efficiency. Pogue received Canadian patent 1938-497 and U.S. patent 2000-26798 for his carburetor. The patents describe a device using exhaust heat to vaporize fuel. The design was mechanically simple, no complex parts, just clever use of waste heat to improve efficiency. Multiple credible witnesses testified about Pogue's fuel economy. A Winnipeg newspaper reporter rode in Pogue's car and documented the fuel consumption. Canadian government officials witnessed demonstrations. These weren't gullible marks. These were journalists and officials looking for fraud and finding none. In 1936, Pogue demonstrated his carburetor for Ford Motor Company executives. They witnessed over 200 mpg on a test track. Ford was interested initially. Then the oil companies heard about it. A carburetor that achieved 200 mpg would destroy gasoline sales. A car traveling 200 miles on 1 gallon meant drivers would buy 1/10 the fuel. The oil industry would lose 90% of automotive gasoline revenue. This was unacceptable. Pogue was offered deals by oil companies. The details vary by account, but multiple sources claim he was offered substantial money to suppress the invention. Some say he was threatened. Others say he sold the patent with the understanding it would never be produced. What's certain is that the carburetor disappeared. Pogue stopped demonstrating it publicly. He never licensed it for production. He spent his later years working on other inventions, never returning to the high-efficiency carburetor. The patents are public. Anyone could theoretically build a Pogue carburetor from the patent drawings, but no one has successfully replicated the reported 200 maybe. Either the patents omit crucial details, or the original claims were exaggerated, or successful replications have been quietly suppressed. What can't be disputed is that multiple credible witnesses saw extraordinary fuel economy from Pogue's car. Even if the 200 mpg claim was inflated, achieving even 100 mpg in the 1930s would have been revolutionary. That engine and carburetor combination disappeared completely. The automotive and oil industries couldn't allow an engine system achieving that efficiency. Cars getting 200 mpg would destroy oil company profits. They would also make conventional engines look obsolete, threatening auto manufacturer sales. So, the technology vanished. Whether Pogue was bought off, threatened, or simply gave up fighting powerful interests, the result is the same. An engine system that reportedly achieved incredible efficiency was destroyed. The technology exists in patent records, but not in any vehicle, because an engine that uses 1/10 the fuel threatens too many profits. The Stanley steamer engine. At the turn of the 20th century, steam cars dominated American roads. The Stanley steamer, produced from 1902 to 1924, was faster, more reliable, and more powerful than gasoline cars of the era. The Stanley steam engine was an engineering marvel that should have dominated the automotive market. Steam engines produce instant torque, full power at 0 RPM. Gas engines need to rev up. Stanley steamers accelerated faster than any gas car. In 1906, a Stanley steamer set the land speed record at 127 mph. Gas cars of that era struggled to reach 60 mph. The Stanley engine required almost no maintenance, no carburetor to adjust, no spark plugs to replace, no complex valve train. Steam engines have few moving parts compared to internal combustion engines. They ran for hundreds of thousands of miles without major repairs. Stanley steamers were also quiet. Internal combustion engines are loud because of explosions in cylinders. Steam engines run smoothly without explosions. A Stanley steamer was quieter than modern electric cars, and this was in 1910. Fuel flexibility was another advantage. Stanley engines could burn any combustible fuel: kerosene, gasoline, wood, coal. Internal combustion engines require specific fuels. Stanley owners had energy independence. They could burn whatever was cheapest or most available. So, why did Stanley steamers disappear? The official story is that gasoline cars improved and steam cars couldn't compete. But the real story is about infrastructure control and oil company influence. Steam cars threatened oil company profits. Stanley engines burned kerosene, much cheaper than gasoline. They could also burn alternatives. Oil companies made fortunes selling gasoline for internal combustion engines. Steam cars using cheap kerosene or alternative fuels threatened that revenue. Starting a Stanley steamer took longer than starting a gas car. You had to wait for the boiler to build pressure. This became the main criticism of steam cars. But by the 1920s, Stanley had improved start times to under a minute. This wasn't a real disadvantage anymore. The actual problem was infrastructure. Gas stations selling gasoline sprang up everywhere. The oil industry made sure gasoline was available nationwide, but they didn't support kerosene infrastructure for steam cars. Without convenient fueling, steam cars became impractical. The Stanley brothers faced constant patent battles and legal harassment. Competitors sued repeatedly, tying the company up in litigation. These lawsuits drained resources and prevented innovation. Many of the lawsuits came from companies with oil industry backing. In 1917, Francis Stanley died in a car accident. His brother Freeland lost interest in the business. The company struggled without their leadership. In 1924, Stanley Motor Carriage Company shut down, but Stanley steamers kept running. Cars built in 1910 were still operating in the 1950s. Some still run today. The engines proved their durability over decades. They needed minimal maintenance and repairs. This was exactly the problem. An engine that runs for 40+ years without major repairs doesn't generate replacement sales. An engine that burns cheap fuel doesn't generate fuel sales. An engine with few moving parts doesn't generate parts sales. The Stanley engine was too good for the business models that came to dominate the auto industry. Internal combustion won, not because it was better technology, but because it was more profitable to sell. Engines that need regular maintenance, fuel that must be refined and distributed by oil companies, complex parts that wear out. The Stanley steamer's crime was being too reliable and too fuel flexible. The EV1 Electric Motor. In 1996, GM released the EV1, the first modern mass-produced electric car. The electric motor and drivetrain were revolutionary. Unlike the engine itself, let's focus on why this particular motor design was destroyed. The EV1 used an AC induction motor that produced 137 horsepower and instant torque. The motor had exactly one moving part, the rotor. No pistons, no valves, no timing chains, no oil pump. One moving part. This motor required essentially zero maintenance. No oil changes, no tune-ups, no spark plugs, no filters. The electric motor would run 500,000+ miles without wearing out. Bearings might need replacement eventually. That's it. The regenerative braking meant brake pads lasted the life of the vehicle. In normal driving, the motor reversed to slow the car, converting kinetic energy back into electricity. Friction brakes were barely used. EV1 owners reported brake pads still at 90% after 50,000 miles. Total maintenance costs were projected at about $50 per year, compared to internal combustion cars needing thousands in maintenance annually. The EV1 electric motor eliminated the entire automotive maintenance industry. This was a catastrophic threat to dealers. Automotive dealerships make more profit from service departments than from the car sales. A car needing no service meant no service revenue. Dealers make nothing on oil changes, tune-ups, and repairs they can't perform. The motor also threatened the oil industry. An EV1 eliminated about 500 gallons of gasoline consumption annually. If electric vehicles became popular, gasoline demand would collapse. The oil industry saw their entire automotive market vanishing. In 2003, despite waiting lists of customers wanting to buy EV1s, GM recalled every vehicle. Lessees begged to purchase their cars. GM refused. All 1,100 EV1s were recalled and destroyed. Most were crushed. Some were given to museums with disabled drivetrains so they couldn't be driven. The electric motors were destroyed too. GM didn't want anyone studying them. They didn't want independent mechanics learning to maintain them. They wanted the technology eliminated completely. The official reason was no market demand, but customers were literally begging to buy their leased EV1s. The real reason was that the motor was too good. It eliminated maintenance revenue, it eliminated oil consumption, it threatened dealer profits and oil industry profits. The motor's single moving part design was particularly threatening. If consumers learned that motors could be that simple and reliable, they'd demand the same from gasoline cars. The entire business model of planned obsolescence would be exposed. GM also owned patents on the motor technology and the battery management systems. After destroying the EV1, they sat on these patents. Other manufacturers couldn't build similar motors without licensing GM's patents. GM wouldn't license them. The technology was locked up. It took Tesla, an outsider to the automotive industry, to prove electric vehicles could succeed, but Tesla had to design around GM's patents. They couldn't use the exact motor design that made the EV1 so reliable. They had to develop alternatives, delaying electric vehicle adoption by years. The EV1 motor proved electric vehicles could eliminate automotive maintenance. That's exactly why it was destroyed. A motor that never needs service doesn't support dealer service departments. GM chose dealer profits over customer satisfaction, and every EV1 and its motor were crushed. The Elsbett diesel engine. In the 1970s, German engineer Ludwig Elsbett developed a diesel engine that could run on virtually any oil. diesel fuel, vegetable oil, used cooking oil, even animal fats. The Elsbett engine was multi-fuel capable by design. The engine used a unique combustion chamber, design, and fuel injection system that could handle fuels with different viscosities and combustion properties. Most diesel engines are optimized for petroleum diesel. Elsbett's design worked with any oil. This was revolutionary for energy independence. Farmers could grow oil crops and run their equipment on homemade fuel. Restaurants could sell used cooking oil as vehicle fuel. Drivers could avoid petroleum entirely. The Elsbett engine eliminated dependence on oil companies. The engine was also incredibly efficient. It achieved better fuel economy than conventional diesels while running on the cheaper fuels. Vegetable oil costs less than diesel. Used cooking oil is nearly free. Operating costs were a fraction of petroleum diesel engines. Elsbett installed his engines in passenger cars, trucks, and tractors. Customers reported running on pure vegetable oil for hundreds of thousands of miles without problems. The engines proved reliable and durable on alternative fuels. The engine threatened oil company profits directly. If vehicles could run on vegetable oil or waste oil, who would buy petroleum diesel? The entire diesel fuel market would collapse. Oil companies couldn't allow this. Elsbett engines also threatened automaker profits. The engines were simple and durable. They ran for decades without major repairs. Owners could fuel them with farm-produced vegetable oil, eliminating dependence on the fuel distribution networks. In the 1980s, Elsbett tried to license his engine to major manufacturers. They all refused. Mercedes, Volkswagen, BMW, all rejected the technology. Not because it didn't work, but because it worked too well on fuels oil companies didn't control. Petroleum diesel interests lobbied against vegetable oil as fuel. They pushed regulations requiring fuel to meet petroleum diesel standards. These standards were designed so that pure vegetable oil couldn't legally be used as fuel without expensive processing. Tax authorities in Germany and other countries began taxing vegetable oil when used as fuel at the same rate as petroleum diesel. This eliminated the cost advantage. If vegetable oil was taxed the same as diesel, drivers had no financial reason to use it. Elsbett Automotive GmbH continued operating into the 1990s, converting engines for customers who wanted multi-fuel capability. But without major manufacturer support, they remained a niche product. When Ludwig Elsbett died in 2003, the company closed shortly after. The engine technology still exists. Some enthusiasts convert diesels to run on the vegetable oil using Elsbett principles. But it's a tiny hobbyist market. The mainstream automotive industry will never adopt it because it threatens oil company revenue. An engine that runs on farm-produced vegetable oil gives drivers complete energy independence. They can grow or buy fuel from local sources. They don't need oil companies, refineries, or distribution networks. This independence is exactly what makes the technology unacceptable to established interests. The Elsbett engine wasn't destroyed through force. It was destroyed through regulatory capture, industry boycott, and deliberate lack of support. The result is the same. A working engine that threatened oil profits was prevented from reaching consumers. The Tom Ogle engine system. In 1977, a 24-year-old mechanic named Tom Ogle demonstrated a modified engine system that achieved over 100 miles per gallon. Multiple witnesses, including reporters and government officials, verified his claims. The system worked by vaporizing gasoline more completely than standard carburetors. Ogle's system replaced the carburetor with a pressurized chamber where fuel was heated and vaporized before entering the engine. Similar to Pogue's design, but with different engineering, Ogle's system achieved the nearly complete fuel vaporization, dramatically improving combustion efficiency. In demonstration runs documented by El Paso Times reporters, Ogle drove a 1970 Ford Galaxy, a massive heavy car with a 351 cubic inch V8 engine, and achieved 150 mpg on highway runs. Multiple witnesses rode along to verify the fuel consumption. The system was tested by independent mechanics who confirmed it worked. Ogle received U.S. patent 4779 for his fuel vaporization system. The patent describes a complete working system. The technology was real. Major automotive and oil companies expressed interest. Shell Oil, and several automakers sent representatives to evaluate Ogle's system. Initial responses were positive, then suddenly all interest evaporated. Ogle claimed he was offered substantial money to suppress the technology. He refused initial offers, believing he could manufacture the system independently. He formed a company and sought investors to bring the product to market. Then strange things started happening. Ogle's workshop was broken into repeatedly. Prototypes were stolen. Documents disappeared. He received threatening phone calls. Someone shot at his car. The harassment was systematic and persistent. In 1981, while trying to secure final financing to begin production, Tom Ogle died at age 26. The official cause of death was drug overdose, specifically a mixture of alcohol and pills. Friends and family insisted Ogle didn't use drugs and rarely drank. They believed he was murdered. After Ogle's death, his patents and technology disappeared. The company dissolved. Prototypes vanished. No one has successfully manufactured Ogle's system commercially, despite the patent being public record. The pattern is familiar. An inventor develops technology that threatens oil profits. Major corporations show interest, then back away. The inventor faces harassment. Convenient death. Technology disappears. It happened to Pogue. It happened to Ogle. It's happened to multiple inventors of high-efficiency engine systems. Whether Ogle was murdered or died accidentally, the result is the same. A working engine system that achieved 100+ mpg was eliminated. The technology exists in patent records, but not in any vehicle. An engine modification that would cut fuel consumption by 70% vanished when its inventor died young. The Stirling engine for automotive use. The Stirling engine, invented in 1816, is an external combustion engine that's more efficient than internal combustion engines. It runs quietly, produces less pollution, and can operate on any heat source. In the 1960s, 1980s, multiple companies developed Stirling engines for vehicles. All programs were canceled. Stirling engines work by heating and cooling gas in sealed chambers. The temperature difference drives pistons. Because combustion happens externally and continuously, rather than in explosions, combustion is more complete and efficient. Thermal efficiency can exceed 50%, much higher than gasoline engines. Ford and Phillips developed Stirling engines for cars in the 1970s and 1980s. These prototype engines achieved excellent fuel economy and extremely low emissions. They ran on various fuels: gasoline, diesel, propane, vegetable oil, or any combustible material. The Phillips Stirling engine achieved 40% thermal efficiency in testing. It produced near zero NOx emissions because combustion temperatures were controlled. It ran quietly, almost silently compared to internal combustion engines. In every measurable way, except starting time, it outperformed gasoline engines. General Motors invested heavily in Stirling engine research in the 1970s and 1980s. They built prototype engines and installed them in test vehicles. The engines worked. They achieved better fuel economy than gasoline engines. They produced cleaner emissions. They were more durable, fewer moving parts, no explosions, lower wear. NASA tested Stirling engines extensively and concluded they were ideal for certain applications. The U.S. Department of Energy funded Stirling engine research specifically for automotive use. By the 1980s, working Stirling engines existed in prototype vehicles. Then all programs were canceled simultaneously. Ford stopped Stirling research in 1988. GM ended their program around the same time. Phillips discontinued automotive Stirling development. NASA's automotive Stirling work ceased. Within a few years, the entire automotive Stirling industry disappeared. The official reasons varied: too expensive to manufacture, starting time too slow, power density insufficient. But these were solvable engineering problems. The real issue was that Stirling engines threatened established interests. Stirling engines last longer than internal combustion engines. External combustion with controlled temperatures means less wear. An engine that runs 500,000 miles without rebuild eliminates replacement sales. Stirling engines can burn anything: gasoline, diesel, vegetable oil, wood gas, hydrogen, or any heat source. This flexibility threatens oil company control. If cars can run on any fuel, petroleum loses its monopoly. Stirling engines need minimal maintenance. No spark plugs, no carburetor, no complex fuel injection, no catalytic converter. The engine has fewer parts and lower maintenance needs than internal combustion. This threatens dealer service revenue. Most threatening, Stirling efficiency improvements would make gasoline engines look obsolete. If Stirling engines achieving 50% efficiency hit the market, consumers would demand the same efficiency from internal combustion engines. The entire industry would face pressure to improve efficiency, cutting fuel sales. So, all Stirling Automotive programs were canceled, not because the technology didn't work. Prototype engines operated successfully, because the technology threatened too many established profit centers. An engine that lasts forever, burns any fuel, and needs minimal maintenance is bad for business. The Joe Cell. In the 1990s, Australian inventor Joe offered a device he called the Joe Cell that allegedly powered engines using only water and a mysterious energy field. The device consisted of stainless steel cylinders charged with electricity. Joe claimed it separated hydrogen from water while also tapping into a natural energy field he called orgone, borrowing from Wilhelm Reich. The claims sound absurd. Running engines on water through a mystery energy field shouldn't be physically possible, but multiple witnesses claimed to see Joe's car running without gasoline. Australian television filmed demonstrations. Other experimenters built cells following Joe's designs and reported similar results. The mechanism was never scientifically validated. Joe claimed the cell created a charged field that the engine could run on. Critics said it was electrolysis producing hydrogen, though the electrical input didn't provide enough energy for the observed output. Skeptics called it complete fraud. What can't be disputed, Joe's car ran without gasoline in multiple demonstrations. Either through hydrogen production, unknown energy fields, or clever trickery, the engine operated. Multiple people built Joe cells and reported getting their engines to run on the device, though results were inconsistent. Then Joe stopped demonstrating the cell publicly. He claimed he was threatened. According to interviews, men visited him and told him to stop working on the cell or face consequences. His workshop was broken into. Equipment was stolen. He received threatening phone calls. Joe went silent about the cell. His website came down. He stopped giving interviews. He told people he'd been warned to stop and feared for his life. Whether the threats were real or paranoia, Joe stopped talking about water-powered engines. The Joe Cell exemplifies how alternative energy inventions are treated. Even if it was fraud, even if the whole thing was a trick, the reaction was disproportionate. Threats, harassment, and suppression over what skeptics claim was just a hoax. Why threaten someone over a scam that doesn't work? The pattern suggests the threat is real, even if the device wasn't. Alternative energy inventors face harassment regardless of whether their devices work. The establishment can't risk letting any alternative energy gain traction, so they suppress everything, working or not. If the Joe Cell actually worked, it threatened oil industry profits existentially. An engine running on water means zero gasoline consumption. Even if it only worked partially or sporadically, it demonstrated an alternative to petroleum. That alone makes it dangerous to oil interests. Whether the Joe Cell worked through hydrogen production, mystery energy fields, or was complete fraud, the response was suppression. Joe was silenced through threats. The technology disappeared. And anyone else trying to develop water-based fuel systems learned what happens to inventors who threaten oil profits. The She engine. In the 1970s, inventor Samuel H. Elliott developed what he called the She engine, a design using multiple cylinders arranged in a unique configuration that reportedly doubled fuel efficiency while producing more power than conventional engines. Elliott's design used opposing cylinders with shared combustion chambers. The geometry created more complete combustion and better thermal efficiency. The engine was mechanically simple, fewer moving parts than conventional designs. Elliott demonstrated the engine to multiple investors and automotive industry representatives. Test runs showed fuel consumption approximately half that of conventional engines, with comparable displacement. The engine ran smoothly and produced good power. Elliott received patents for his design. He formed a company to manufacture the engine. He secured some initial investment. Production appeared imminent. Then suddenly investors pulled out, funding disappeared, the company collapsed. Elliott claimed he was pressured to stop development. He told friends that he was offered money to abandon the project and sell the patents. When he refused, investors mysteriously lost interest. Funding sources dried up. He couldn't secure the capital needed for production. The engine designs still exist in patent records, but no one has manufactured SE engines commercially. Elliott spent years trying to revive the project, but couldn't secure backing. He died in 2003 without seeing his engine produced. The pattern repeats: efficient engine design, successful demonstrations, initial interest, sudden withdrawal of support, technology disappears. Whether through direct suppression or simply denial of resources, the result is elimination of a threat to fuel sales. The Fibreglass Engine. In the 1970s, inventors experimented with fiberglass engines, using advanced composite materials instead of metal. Fiberglass engines were lighter, ran cooler, and didn't corrode. The material's properties also allowed designs impossible with metal. Several prototypes were built using fiberglass cylinders, heads, and blocks. The engines ran successfully. The weight savings improved vehicle efficiency significantly. The thermal properties improved combustion. The engines proved the concept worked. Then fiberglass engine development stopped completely. No manufacturer pursued the technology. Research funding disappeared. The programs were all canceled within a short period. The official reason was that fiberglass couldn't handle combustion stresses, but prototype engines operated successfully for thousands of miles. The technology existed and worked. The real issue was that fiberglass engines threatened established manufacturing. Metal engine manufacturing requires massive infrastructure, foundries, machining facilities, metallurgy expertise. The auto industry has billions invested in metal engine production. Switching to composite materials would make this infrastructure obsolete. Fiberglass engines could be manufactured with simpler processes. Smaller companies could potentially produce them without the massive capital requirements of metal engine production. This threatened the industry's barriers to entry. Most threatening, fiberglass engines didn't corrode and handled heat better. They would last longer than metal engines. An engine that doesn't corrode or warp from heat could run 500,000 plus miles. Longer engine life means fewer replacement sales. So fiberglass engine research was abandoned, not because it didn't work, but because it threatened established manufacturing and would produce engines that lasted too long. 10 engines that never broke down and were destroyed. The Tucker engine designed for 150,000-mile durability that threatened planned obsolescence. The Pogue Carburetor achieving 200 mpg that would destroy gasoline sales. The Stanley steamer that ran for decades on cheap kerosene and any alternative fuel. The EV1 Electric Motor with one moving part requiring zero maintenance. The Elsbett diesel running on vegetable oil and eliminating oil company dependence. The Ogle system achieving 100 plus mpg before its inventor died mysteriously. The Stirling engine achieving 50% efficiency that threatened the entire industry. The Joe cell running on water that brought threats and violence. The She engine doubling efficiency that couldn't find funding. The fiberglass engine that couldn't corrode and would last forever. None of these engines failed mechanically. The Tucker engines still run 75 years later. Stanley steamers operated for decades without rebuilds. The EV1 motor had one moving part that would last 500,000 plus miles. Elsbett engines proved multi-fuel capability over hundreds of thousands of miles. These engines worked. They were reliable. That's why they were destroyed. An engine that never breaks down is catastrophic for the automotive business model. Manufacturers make money selling new cars. Dealers make money on repairs and maintenance. Oil companies make money selling fuel. Parts suppliers make money on replacement components. The entire industry depends on engines that wear out, break down, and need regular service. An engine running 150,000 miles without service means no maintenance revenue. An engine achieving 200 mpg means 80% less fuel sales. An engine with one moving part means no repair business. An engine running on vegetable oil means no petroleum dependence. These engines threatened billions in profits. so they were destroyed. Through patent suppression, through withdrawal of funding, through regulatory capture, through industry boycott, through harassment and threats. Through convenient deaths of inventors, through deliberate lack of support, through any means necessary to eliminate the threat. The pattern is consistent across all 10 cases. An inventor or company develops an engine that's too good. Initial interest from industry, demonstrations proving functionality, then suddenly support disappears, funding evaporates, or the inventor faces threats. The technology is eliminated regardless of how well it works. Tucker was prosecuted on false charges. Pogue's technology vanished after oil company intervention. Stanley steamers lost infrastructure support. The EV1 was crushed despite customer demand. Elsbett couldn't find manufacturer partners. Ogle died mysteriously. Stirling programs were all canceled simultaneously. Joe faced threats and went silent. She couldn't get funding. Fibreglass engines were abandoned despite working prototypes. The technology exists. The patents are public. The prototypes ran successfully. But the engines don't exist in production vehicles because the automotive and oil industries can't allow engines that last forever, achieve extreme efficiency, or operate on alternative fuels. We could have engines running 500,000 miles without major repairs. We could have fuel economy exceeding 100 mpgs. We could have engines burning vegetable oil or any alternative fuel. We could have electric motors with one moving part lasting decades. We could have steam engines running on any heat source. We have none of these because they're bad for business. An engine that never breaks down doesn't generate replacement sales. An engine that uses a fraction of the fuel doesn't support oil profits. An engine that needs no maintenance doesn't support dealer service departments. The engines that work best for consumers work worst for industry. So the engines that never break down are destroyed, suppressed, or prevented from reaching market. Not because they don't work, because they work too well. 10 engines that were too reliable to sell. 10 demonstrations that the automotive industry doesn't want durability. It wants planned obsolescence. 10 proofs that in the automotive business, engines that last forever are bad for business, so they are destroyed before consumers can benefit from them. The technology exists, the engines work. They're just not allowed to exist in your car.